Welcome to the introduction video in my entity component system tutorial. So this is basically what is an entity component system and why should we care about what an entity component system is and where it plays a role in our programming. So the main goals I have here in this video is I'm going to be covering the basics of what it is, what an entity component system is, and then I'm going to be covering the pitfalls of object-oriented approach that the entity component system tries to cover and where it tries to fill what the gaps are in the object-oriented model. Next, I'm going to go into the details of what the entity component system is and how it can benefit us. And then I'll probably cover a little bit of where I might want to go with this particular implementation of it that might be a little bit outside the scope of what people normally think of as an entity component system. So first we cover the entity component system basics, and this is going to be primarily the entity and the component. It's an entity component system, right? So with the entity component system, we've got two main things. We've really got a few other elements I'll get into in a moment, but the entity is essentially, it's really nothing. Like in Unity, when you're working with entity objects, the game object, it's got all kinds of stuff stacked on top of it already. It's got all kinds of behaviors. It's got parents. It's got transforms. It's got all kinds of stuff pre-baked into it. With our entity component system, we're going to have none of that in the entity. The entity really is just a holder for components, and components are data only. So really what we're doing is we're taking those and putting them into the entity component, the entity. So the components are going into the entity. And as you can see, I've stated, data only. So the components, they're not going to have anything else in them besides just data. I'll go into that a little bit more later. But it might be a little bit more accurate if I kind of just call it a list, not so much like a table or something like that, because really you can only really have one in each one, and it's really just a list of the components that make up the particular entity. I'll go into that more later. Now we have a pool, and I've represented this with a box because basically what the pool is it's just a place to shove everything else. And so really this picture is a little bit deceptive because the components in our system, the way we're going to be implementing it, the components are going to be referenced in the entity, and the entity is going to control that, and then there's going to be a pool directly there. But depending on your implementation, maybe if you were running in C++, you might do it differently. You might actually keep a list of all of the components and just reference them in the entity by ID. But with this, we're actually going to have pointer references, because since we're in C#, it's just going to work better that way. Now, a system. Systems, basically what they do is they watch the entity pool, and they're going to go and you can say things like, hey, I want to watch all of the entities that are in the pool, and anytime an entity with a position and a velocity is added, anytime that exists in there, every time I run, I want to take that velocity and I want to apply it to the position to change the position by the velocity. And that's how you build all of your systems out, is systems. Now, another thing that I'm going to be introducing that's not in all of the entity component systems that I've seen is tags. They're basically just components, but they have absolutely no data. They're markers. It's a way to tack data onto your entity to be able to mark it. Maybe you might want to say, hey, this entity is a player, or hey, this entity is an enemy, or this entity is on team. Well, actually, team you would use a component, but you might want to mark it however you might want to mark it. And tags are a way for us to do that in a more efficient way so that we're actually not dealing with full entity component objects. And we're just saying, hey, this entity has these tags. We'll go into that more later. So that's pretty much the basics of the entity component system covered. Now going into the pitfalls of the entity component system. That's where I'm going to have to go and talk a little bit more in depth about the structures we might use for projects. And with this, we're going to be kind of sticking to the game scope. So we're going to be starting with a game object. Like, let's look at if we were doing just a regular plain object-oriented game object. You know, we could break it down into behaviors and things like that. But if we're looking at a pure object-oriented approach, our game object, say we want to make an NPC. That NPC is going to be deriving from our game object, so that we can go and say, hey, that NPC is, you know, a thing, right? That NPC exists in our game world. So next, say we want to go and we want to add a monster, a merchant, and a quest giver, right? Those are all different types of NPCs, right? So what do? We just go and we use our hierarchy, and we make each one inherit from NPC. So NPC goes down into each one. And we've got all the, whatever we've got in NPC, say its position, its velocity, all those sorts of things, they're all tied up in what an NPC is. Now we've tacked on the monster behavior. So, you know, maybe it attacks, it does, you know, whatever. It's got, you know, wandering AI or whatever it is that defines a monster in our game. Then we have, you know, the merchant. It can sell you things and trade with you and all that jazz, and has an inventory and all that good stuff. Quest giver, of course, is going to behave very different again. It's going to have quests and things like that, right? And this is great. It lets us, you know, go and inherit everything. But where it breaks down is, say we want to add a merchant with quests, right? So we've got the merchant with quests. Now, we want that to have a merchant, so we're going to inherit from merchant, right? But we also want it to have quests, right? So we want it to be quest giver. But the problem comes is, where do we inherit? Because most languages that I know of, at least, you can only inherit from one or the other. You can't have multiple inheritances. I know there are languages that do it, but I'm not very familiar with them, and C# is not one of them. So, you know, this again breaks down with monsters who sell things. With monsters who sell things, again, you know, it's a monster and it's a merchant, so where do we inherit from? And usually what ends up happening, if people are trying to stick rigidly to the object-oriented approach, they're often going to go and push all this up into the NPC, right? And so that's going to collapse the structure down and just put tons and tons of bloat into the NPC, and then we get this big monster of a program that is just this huge, unwieldy NPC, and if we change anything in it, it's likely to break 5 different things that we didn't even think of, you know. I don't know if you're an amazing programmer and you can keep all those different references in your head, but I can't. And so what we need to do is we need to move on from that, right? And what we're going to do is, the first thing, we're going to start breaking things away. We change the game object into an entity like I just did, right? And we're going to detach that. So it's no longer, the NPC is no longer a inherited. So it's not inheriting from the entity component system. So now we're bringing it into the entity component system, right? So the entity, we can start constructing an NPC. So what is the NPC actually, right? The NPC is a position, right? So we're going to add a position component to it. We're going to add a velocity component and a direction component, right? And then we need to be able to see it, so we're going to add a render model, and it needs to be able to die. So it's going to have a health of some sort. It might have a crazy amount of health if it's supposed to be a long-term NPC that's super strong or whatever. But that is basically our representation of an NPC. So we can take that, we'll put that aside. That's under entities, right? So that's an NPC. That's kind of how we're going to define an NPC, is that, right? And that's an NPC right there. That's in the entity component system. That's the NPC, and we can have various systems that operate on each of these different things and do what it needs to do. You know, like a system that when an NPC, or rather not an NPC, but an entity has a position and a renderer, then it's going to go and it's going to take our render code, and it's just going to grab those two, and it's going to shunt those over into our render code and say, hey, render this, whatever it is that our renderer does, right? Whatever it's referencing, an image or animation or whatever, render this at that position that you're supposed to render at, right? Same thing with, as I was talking about earlier, position and velocity. Same thing. Anyway, so we can move on and we can take our next one, the quest giver, right? So we'll take the quest giver, and we're going to, now the nice thing about entity component systems is, since we're kind of making like blueprints, so to speak, or you know, some kind of template, right? We can just say, hey, let's import everything from the NPC. This is kind of like our inheritance, right? But we're actually we're taking each one of those objects, you know, we're going and we're adding a health object, we're adding a position object, we're adding a velocity, a direction, and a renderer to this new one. But what's different, right? What was the thing that's different about a quest giver, right? It offers quests. So we do that. Let's go ahead and shunt that over. Now we've got our quest giver, and we can see we just tacked on the offer quests onto the end. So merchant is very similar. We're going to import the NPC, we're going to add trading, we're going to add an inventory, we're going to throw that to the side. Monsters are basically the same again, so we're just going to import NPC, and we're going to add an attack this time though, and add an inventory, and then we're going to add a tag that says lootable. And this is where I was talking about those tags, remember? Now we just say, hey, it is a lootable thing. So what that means is there's going to be some system that will go, and when this NPC dies, it will, or when this entity dies, it'll take everything that's in the inventory and drop it on in the game space. Just drop it into the game space where the entity was. And that allows us to have that rich behavior, but still in a very modular form. So we take that, bring that in as well. Now we've got these two left, and we can move those over to the side. Now these are the hard cases, right? We were looking at it before and we're like, okay, where do we inherit from? And so now let's take the monster who is a quest giver, or sorry, merchant who is a quest giver. Where do you think this would go? What do we do next, right? Do we import the NPC? What do we import? Well, we can do something a little bit tricky here, which is nice. Since we've got this cumulative templating system, we can actually just go and we can import the merchant. And then we can import the quest giver. So now what that does, we have these two lists of components that make up each of those, right? But we've got it all defined by systems. So all of these are just simply things that are just tacked onto it that create what the object does. So all we have to do is our template system goes, and you know, we've got right now health, position, velocity, direction, render. So how do we resolve that, right? It's really simple. We can only have one of each on the object, so we just eliminate all of them, and it's not a problem anymore. So then we get rid of those completely. Now we've got our two trees. We just insert the quest offer component into the merchant quests, or the merchant with quests. And now we have a merchant who gives quests, right? So now we can look at the monster merchant, right? Same basic thing. We just import a monster, import merchant, throw them together, eliminate the ones that are duplicates, and then now we've got that there. Now, what if we wanted to go and we wanted to make a merchant, or sorry, not a merchant, a monster who was a merchant, right? Or, sorry, we already did that. What if we wanted to go and take the monster and make a monster who gives a quest? What do we do then, right? That, again, is really simple. All we got to do is make another one. But this time we give it the offer quests instead of the trade. And there you go. Now they can trade. You might want to do this slightly different so that someone couldn't just kill the merchant and steal all their stuff. But at the same time, maybe you do want them to be able to just kill the merchant and steal all their stuff. If you're making a really simulationistic game, that might be a desirable thing and an interesting feature that people might be able to just find. But anyways, that covers basically the pitfalls of object-oriented approach versus how we would solve those sorts of pitfall problems with ECS. So going forward, we can cover the more in-depth version of what the entity component system really is at its core and how we plan to implement it. So covering the components first, right? The components are really the heart and soul of the entity component system. You know, they're what makes this so interesting and so much more powerful than a lot of the other methods of how you do things. You know, there's other variants on it, like event component system or component systems, or just simply entity component applications. But with an entity component system architecture where you're doing it all, you want your entity components to just have pure data. So that means no function calls, you know, no methods at all. You don't want to be calling out to anywhere from your components, except really weird special edge cases dealing with weird stuff low level, like networking and things like that. Sometimes you do want to do stuff to just make your life a little bit easier down at that low level. But generally speaking, you shouldn't have to ever put any logic in your data structures. You know, nothing in there. But secondly, you don't want to do something like, say, make a player component that has a bunch of positions in it and a health and, you know, where they spawn and stuff like that. You want to break that out. You want to have a spawn position. You want to have a position. You want to have a velocity. You want to have a health that are separate things. One logical concern for each thing, so that the systems can go and they can do whatever they need to. But because of the way we're going to architect it, and I'll talk to you about signatures later, but the way we're going to design it, the systems will be able to go and grab whatever they need. So a system just simply says, hey, I want to know about anything that has a position and a spawn position and the player tag, right? And then it says, well, that's a player, of course, right? So that says, hey, these are the players in the world, right? Or a player ID tag, maybe, or whatever. But that can be completely separate, and that doesn't need to know about how the player is moving around. So another system entirely says, I want to know about everything that has a position and a velocity, and I don't care what it is. So that'll control everything from players to NPCs to floating birds or dust in the whatever you want, you know. The next thing is the entities themselves. You know, we're going to have a lightweight signature check, which, you know, I'm going to talk to you about a little bit more in detail, the signatures, but basically what it means is it's a simple way to really efficiently go and check what components are in the entity, and very quickly be able to match what we want to what's in the component and say, hey, does this component have the things that we want to find? And if not, we can move on, right? And I'll go into that in more detail later. Pointers to the components. So with that, that's basically talking about how we're not going to have lists in the background that have every single position in it, and every single velocity, and every single spawning position, or every single health component. We're just going to go and link them out from the components system, and that's that. And then if we destroy it, then we'll let them go, and we'll be all good. You might think that might generate a lot of garbage. We'll cover that in the next slide. Lightweight tags. Like I was saying, those tags, instead of having to actually have components with pointers and actually putting an actual instance of an object into there, we'll probably use something like hash sets, so that we can just really quickly say, hey, do we have tag number 3? Or do we have tag number 4? Or whatever, or do we have tag number 3, 4, and 10? Without having to go and actually follow any pointers and check what type that pointer is and all that jazz, right? We don't have to actually deal with any of that at all. So going back to the garbage that the pointers and releasing the pointers will cause, what we're going to do is we're going to go and use a cache system. So what we'll do is whenever the entity no longer needs the components, like when the entity is a reset, or when the entity has a component removed, or when the entity itself is removed and thrown back into the cache. All of those situations will take the components that are on it, and we'll throw those back into a pool. We'll clean them so that we can, have default values in them if we need that. And then we'll throw all that back into a pool. And that's that, right? It's all set up, and we don't have to worry about generating tons of garbage, because we're not going to be creating new objects if we have the objects available. And most importantly, we're going to be holding on to a reference to that object at all times, so that the garbage collector will not go and grab that object and try to clean it up for us. Normally, in most programs, garbage collection is awesome. But in a video game, especially if you're doing a VR game, the garbage collector is your worst enemy. You don't want the garbage collector to be triggered. If you can avoid it. You're going to have to do a little bit of garbage collection here and there, but that's acceptable. But what you don't want to do is you don't want to generate a ton of garbage. And if we were just throwing away these components and just creating new ones, just throwing away the old ones, we would be creating a lot of garbage, because sometimes we're going to be instantiating like 100 elements in a frame and throwing them away in the next frame, which sounds really, really, really wasteful, except when we're using the caches. Then we're not wasting them. We're just using them, letting go of them, using them, letting go of them. So if we're generating 100 one frame, letting them all go the next frame, and then 2, 3, 4 frames later, doing another 100, instead of just having created 200 objects that we just lost, right? And the garbage collector has to deal with in a matter of 5 frames. Now we've only generated 100 objects, but also we still have the objects. The garbage collector isn't going to be doing anything about it. It's not going to care. So as I say here, entities and component cache equals win. So next is entity handles. So with the fact that we're going to be recycling everything from components to entities and all those things, we want to be able to have a way to reference an entity that is not a actual direct reference to the entity, because we need to go and access its components through the entity directly, not through a direct reference to a component, because they could change. What if the entity, the component is removed, or that component's removed but a different one is added? If that's the position, we'll still be looking at the old position. We can't do that. We need to look at whatever is currently on the entity, and removing and adding components might change what the entity actually is in our game, and if we're holding on to references to its components, we won't know. We won't know that it's polymorphed into something else. So the main thing that you need to know here is I'm going to be introducing phase, right? I don't know if any other entity component systems use this, but it's what I'm calling phase, in phase and out of phase. So when when we have an entity handle, right? We generate a handle by asking the entity for its handle, or just calling handle and saying we want an entity for X handle, right? Or for X entity, and we just pass it an entity. Then we want that handle to be able to give us the entity, except if the entity has gone out of phase. So what I mean by that is anytime we recycle an entity, meaning we shut it down, we strip off all of the components, we reset its values, and throw it back into the queue to be used if we need a new entity later, if we need to create a new entity at a later point in time, right? So when we do that operation, that full circle operation, when we clean it and throw it back into the queue, we're going to increment its phase. And so that means that its phase is going to be one higher than it was before. Now, our handle object is going to have a copy of that, right? It's not going to be a reference to it. It will have a reference to our entity, but that's going to be a protected reference. It's going to be a read-only reference that is based on the phase. So whenever we ask for the entity, the handle will look at the read-only phase and check it against the current phase of the entity. And if the current entity's phase does not match the phase of the handle, then we're going to return null, because we never, ever, ever want to return the entity to wherever needs the entity if that entity is no longer representing the entity that whatever originally was looking at. I know that might sound a little bit confusing, but basically what I'm saying is we're going to have a handle which will only ever represent the particular entity that we need. So if we grab a reference to an entity and then that entity is destroyed, we don't have to worry about it, because any other system that asks for that entity is not going to get the entity that's in storage or is now something else. Like, say for example, we have an entity that's a player, right? Then we destroy that player object and we create a new object that is, say, an enemy, or who knows, maybe it's a piece of the UI or something, whatever that entity is. The old reference to the player, if somewhere goes, hey, there was a player at one point and it was an entity and here's my handle to grab that entity, it's not going to go and grab that new piece of UI or the monster, the NPC that it is now representing. The handle will technically still have a reference to that entity, but it won't matter because the handle has a little bit of logic in it to whenever we request the entity, it will check to make sure that it's in phase. And because we have this phase on each object, we don't have to worry about some kind of weird thing with, going out, because it's extremely unlikely that we're going to use any entity the amount of times that we're going to be dealing with in the scope of the max int. And even if we did, it's extremely unlikely that we're ever going to have a handle that we're still holding on to at the point that we've used that entity enough times that it comes all the way back around to that. Because, we'll go up across the top border, then loop back down into negative and come up to, say it's, its handle is 5. We'd have to go all the way up, then go all the way back down to the very bottom at like negative whatever it is that the max int is, right? Then come all the way back up to 5. If we hold on to a handle that long, we've got way bigger problems in our program than, this. So it should work perfectly fine for us. Loops are evil. Well, I mean, they're not. They're crucial to what we do. But when you're trying to make a fast system, looping through tons and tons and tons and tons of things is just terrible. So instead, what we can do is we can use groups. With groups, we're going to go and we can say, hey, I want a group that has every entity that has a position and a velocity, right? And yes, when we initially request that, it will take a little bit. It'll be a little bit slow because it's going to have to go through and look at every entity in the system and say, hey, do you have these things? And look through each thing and find the signatures that match, right? But after that, we can just hold on to that in the background. And then if any other piece of our code says, hey, I want a group that has a position and a velocity, we say, oh, it just so happens I already have this group. Here you go. And whenever a new entity is created, we just simply check that against every group that we have available. And we say, hey, all the groups, do you care about this entity? If so, it's a new entity. Go ahead and add it to your group. Right? And so that will allow us to go and deal with that. We don't have to worry about, hey, okay, so let's loop through and find all of the position, all of the entities that have positions and velocities every single frame. Instead, we just loop through a group that only has the positions and velocities. So we don't have to worry about anything else. We could have thousands of other entities, millions of other entities that don't have positions and velocities, and maybe only have 300 that have positions and velocities, and instead of having to loop through thousands or millions every frame, we only have to search through those 300, which can be quite quick, especially if we're barely doing anything or doing a simple calculation on each thing. It's menial amount of time. So that covers the details, the nitty-gritty of the component system, and at the detailed level. So, optional things that we could do. Now, remember when I was talking about events earlier? Events could be a lot of fun. Now, I'll have to go into this more later, and I need to think about it more to see if I want to bring this in, but I might want to bring some kind of an event structure in so that we're not dealing with our only option being systems. And then that way we can either fire an event or use a system, so that we don't have to have a system for every little thing, and we can have a just some kind of event responder or something like that responds to certain kind of events, maybe like a particular type of object getting destroyed or what have you. But I'll have to I'll have to think about that some. Now that's all I had, but I did just think of one other possible area we might want to go into that I actually just forgot. I don't remember it anymore. Sorry, it's like 3 in the morning when I'm talking to you, so I'm a little bit on 3 o'clock brain at this point. But I hope this has been maybe even informative, but I hope this is giving you an idea of where this system we're going to be building is going. And I hope to soon have the first episode out. I think the first episode is going to be on building those handles we were talking about, because those handles we can really build in a vacuum without really needing any of the other systems in place for, you know, caching anything or doing any of those other things, because really we're just looking at, hey, you know, if it increments, then, you know, if it goes out of phase, if it phases up, right, then does this handle still work or not? And if it doesn't, we're good, right? And I'm going to try to bring in a like a test-driven development sort of procedure to it. At any rate, if you like this, and if it was informative, or if you just want to say hey and thanks for doing the tutorial or whatever, make sure to hit that like button down in the bottom, because that would be awesome. And if you want to ask me to cover anything, you know, I'm totally open to bringing in new ideas into this. Comment down in the doobly-doo. Or if you didn't understand any part of this tutorial, definitely comment down in the bottom. Ask me questions. I will answer. I mean, as long as they're not like stupid questions like what color is the sky. Be warned, if you ask me what color the sky is, I'll probably say something like purple, just because lols. Okay, hope to see you in the next video, and have a great day, and I'm gonna go get some sleep.